Hello everybody, welcome to your 5-1 lesson on the absolute value function. Our learning target for this lesson, we are going to analyze functions that include absolute value expressions. We're going to be able to graph an absolute value function and identify the key features of the graph. We're also going to calculate and interpret the rate of change of an absolute value function over a specified interval. So let's take a look at some vocab that we need in our notes. First is the absolute value function. This is f of x equals the absolute value of x. So that is the absolute value function. We call that a parent function. There have not been any transformation, so it's going to be the most basic absolute value function we can have. Let me just show you a sketch of what this looks like. So if here we have your x and y axes, the absolute value function looks like this. So that's what the absolute value of x looks like. All right, so axis of symmetry. All right, your axis of symmetry, that's going to be a vertical line that divides the graph into two sections that are images of each other under a reflection. Your axis of symmetry is going to be the equation x equals 0. If we look at our parent function, we can draw a vertical line right here that's going to divide the graph into two sections where this side on the left is a reflection of that side on the right across this axis of symmetry. It's basically a symmetry line. If we have just the parent function, the most basic, that symmetry line is at x equals 0. All right, then we have a vertex. So our vertex is going to be the highest or the lowest point on the absolute value graph. So just to give you a couple quick examples, here's an x and y axis. If we have the parent function, f of x equals absolute value of x, the vertex in this case would be the lowest point, right here at 0, 0. That's the vertex. It is possible to have a transformation of your absolute value graph where instead of that V shape opening up, it's actually opening down like this. Now our vertex is right here, and that is the highest point of the graph. So your vertex can be the lowest point if it's opening up like our parent function does, or if we've applied a transformation where it's now opening down, your vertex is going to be that highest point.